All right, so I got people guessing 28. Which is kind of weird. That's normally not the very first guess I get because of the way I said it. The 80th percentile should be the number that has 80% of the data below it.
29.
So another guess is 29. But if it's got 80% of the data below it, it should have how much above it? 20%. Okay. So, in a way, everybody's right and wrong at the same time. So, you're right because you kind of made one of those things work. But everybody's wrong because it doesn't do both things. So you're all like, what the freak do you want from me? Jeff, there is a number that I can calculate that does both of those things.
20.5.
Exactly. Average those two. 20.5, how many data points are below it? 8. 80%. 8 out of 10. How many data points are above it?
20.
2. 2 out of 10, 20%. You guys with me so far? Okay. So one thing I want you to realize from this simple example is the percentiles, there's a little bit of an adjustment to make sometimes. So I want that to make sense when we hit it in the process we're going to talk about. Okay, all right, maybe. Maybe. Okay. So here's the actual calculations that you run through. And this is where I differ with the book a little bit. To find the 80th percentile, and let me show you what it looks like in symbols. This means 80th percentile. Right, P sub 80 is the 80th percentile. We're actually going to see this symbol pop up many times through the whole semester. It's always going to mean the same thing, but I'm going to have different ways to find it based on what we're doing right then. All right, I love it. Most of you are like, I don't know what to make of that, Jeff. Stop talking. Okay. So to find P80 is always a two-step process. The first step is where is the answer, and the second step is go get the freaking answer. Some people stop at the first step, and that's you don't have the answer yet. Shit. So what makes sense here? So it makes sense that the first step should be, if I want the 80th percentile and it has 80% of the data below it, I want to go how far into the list? 80% of the way into the list. Does that make sense? Mm-hmm. Of course you do that. I'm going to make sure that I bypass 80%. And then the adjustment's going to come in. Because you see that that's not going to really work correctly. So I want to take 80% of, in this case, how many data points?
10.
10. So it's not always 10. People always key in on the wrong thing. It's however many data points you've got, right? So it's this percentage of n, the total number of data points you got. So what is 80% of 10? 8. I like it. All right. All right, you guys ready? Mm-hmm. So if it comes out to a whole number, you average that one with the next. So you don't take the 8th number, you average the 8th and the 9th, which is exactly what we figured out already makes sense in this case. They let all that sink in. So if it comes out to a whole number, you average that one with the next. You average the 8th with the 9th. And of course, so that's where the answer is, and then what the answer is will be 28.5. Bless you. All right, now, what if it isn't a whole number that I get after this first step? So let's figure out what what do you got, Jeff? P75 is going to be. So what's the first step to figure out P75? Hey, let me see. Can somebody turn the lights back on for me? I just realized why it's so mood lighty in here. And bring out the little candles for us. So what's the first step to figure out any percentile? I take that percentage of the how many data points? 11. So 75%, so 0.75 times 10 is, of course, 7.5. It's amazing. Right? Multiply by 10 with the decimal over. Is that a whole number?
No.
Hell no. If it comes out to a non-whole number, you round it up to the next whole number, and that's the answer. That's where the answer is. So you round it up to the 8th number, and what's the 8th number? 28. I like it. So P75 equals 28. Sure. So it's always the same two steps. You take the percentage of how many things are in your list, which should make sense. I want to go that deep into my list. Now, real quick, what was I careful about when I made this list? What's got to be true, your list has to be in order, or else you could just make anything. You just move that there and move that there, and I'm the 100th percentile. No. It's too damn bad. All right, maybe. Yes?
So if it comes out to like 7.2.
Beautiful, I love it. So how do we find P62, for example? Let's do P72, sure. Why not, Jeff? What's 72% of 10?
7.2.
7.2. So I'm going to round it up to
8.
8. So the 8th number is?
20.
28. Now going back real quick, just to remind you guys, why is it also 28? Because there's only freaking 10 numbers there. So you can't make such good resolution. There can't be a different number for P75 as there is from P72 because there's only 10 numbers. Now if I had 100 numbers, P75 and P72 could be different totally. Plus I had a lot of repeats right there. Does that make sense?
Mm-hmm.
If I have 100 numbers and P1, P2, P3 pretty much lines up with the numbers, right? There's enough numbers so that everybody gets their own. Does that make sense?
Mm-hmm.
Shit, all right. I'm going to go with the verbal of a few people saying yes and the rest of you going. All right, let me see. I mean, that's really all there is to percentiles, to be honest. The book has a slightly weirder way to do things. So that's why I don't do it that way. What do you think is about P75 that's special? I mean, anybody watch football or basketball or... okay, a few of you guys. Hey, I love you. Everybody else is like, I don't watch anything. Football? What? So, or what else we got? Anything else? With quarters is what I'm trying to say. So you break something down into quarters. 75% of the way through the thing means you're at the end of the...
Third quarter.
So this is where the third quartile. So this is the 75th percentile, which is also known as the third quartile. You could also break them into deciles, but I'm not going to do that. P10 is the first decile. Screw that. We'll just stick with Q1, Q2, Q3, Q4. All right, I like it. It's no Q4. So let's do this. We've already got Q3. You guys help me out here. Figure out what Q1 and Q2 are. We know what Q3 is, 28. You guys take a minute and figure out what Q1 and Q2 are from that same list of data. If you need some help, call me over or ask somebody near you. So 2 steps. Q1 is P25. 25. So I'm going to take 25% of 10. Not a whole number, so I make it third number. So Q1 equals 1, 2, 3. Yay. Now real quick. Normally this is the other way this happens, but to get to Q3, I had to go how far from the top? 1, 2, 3. So Q1 is symmetric on the other side. Does that make? If that doesn't make sense, you can just do what I just did. But that's nice. Bam, bam, bam. That's a quick way to do it. Right? Q2 is also known as something else. It's called the median. Just like the median is in the middle of the road, Q2 is going to be the data point that's exactly in the middle of all the data points. So Q2 is also P50. So Q2 is freaking everything. Q2 is P50. It's freaking the median. Freaking. So I do the same thing. 50% of 10 is amazingly enough 5. What does that mean?
You have to
take the 5th and the 6th and average them. I like it.
22.25, maybe.
So 1, 2, 3, 4, 5, 6. So I'm going to average those. How far apart are they? 3. Cut that in half and add it to the smaller one. 22.5. I like it.
Cool.
Or add them and divide by 2. Whatever you like better. All right, now. Again, we haven't. Yes, sir.
Why for Q1 you just go 14 like 1, 2, 3, and but for Q2 you
Yeah,
go
it would be
5
12.
or 6.
Because it was a whole number.
I got 12 first. I know what he's saying.
You got 12 first? How do you mean?
Because if you go up to the second, it would be 12.
Where's 12?
17. There is no 12.
There's no 12.
Right.
So we're
But on the 50, there's no 22.5 either. But you're going in between.
Going in between.
because you have to.
Because this came out to a whole number.
Right.
Came out to 5, so I got to go between the two. It's related to the idea of if I have 5 numbers, which number is in the middle? The third number. Well, what's half of 5? Oh, 2.5. So I better round up to 3, so it's actually the number that's in the middle. So it's related to that idea. That's how you find the median, right? It's just cut it in half and then round up. Yeah.
So it's a whole number.
Take that one and average it with the next one up.
And it's like the.
Anything else, you round up and take it.
But it's the next number that's there.
Yeah,
not
so
the
that came out
next
to 2.5. I round up to 3, so the third number is the answer.
third.
Yes, sir.
So if you came out to 2, you would take the average between 11 and 17.
Yeah, if I came out to 2, whole number, I got to average the second one with the third one. I like it. Then you get 14. Okay. So everybody some ideas in there. And again, it doesn't make the most sense, to be honest, when you have a small group of data, but it's a lot easier to do the work with a small group of data. So don't, there's no resolution here. It's only 10 data points. So there's not enough resolution to really kind of pick it apart. Yet, when you get a larger set of data, now you can start to see how it gets picked apart. Then there's more data points to be each one. Here, there's only 10 data points. So there's going to be a lot of repeats. Yeah.
Are we only going to see like P's and Q's? Or are we seeing others?
For me, it's just P's and Q's. So mine those. Sorry. But there are D's, there are deciles, right? Just gotta love to say deciles. All right. So please don't let that be a huge problem. That's not calculationally intense. But now what we can do is we can make the next strangely named graph. It's called this book calls it a box plot, but it's actually officially known as a box and whisker plot. Oh shit. So again, everything we're doing is, if I had 2 separate sets of data and I make a histogram, like if I had a histogram of father's heights, histogram of mother's heights, it's a very quick way to compare the two. If I make the scale the same, I can see that, of course, the mother should be lower. Some women will be tall, but most of them should be smaller than most of the men. You guys kind of with me? Shorter? Just the way things are biologically. So if I had like grades from one stat course or another stats course, I can make histograms and compare. Or I could do a box plot, which is going to capture information about the quartiles. Quartiles, right? And just to make sure we understand, this is what's called a measure of position. That should make complete sense. Because when I'm saying Q3, that is a position in the data, right? That should be 80% of the way in. So that's why this is a measure of position. Then next we're going to talk about a measure of center, which we're talking about averages. Median's going to come up again because that's a way to think about center, so forth. You guys, and then we're going to talk about measures of variation, spread. And some of you guys know what that's all about. We'll get there. Okay, so box and whisker, all this is it involves something called a 5-number summary, which is just the lowest data points, Q1, Q2, Q3, and the highest data point. Now let me let that sink in. It should kind of make sense that this is a nice way to break your data up. So you go in steps of 25%. Start at the lowest, 25% up, where are you? 25% up, where are you? 25% up, where are you? And then 25% more, you should be at the end. Makes some kind of sense. So what does this look like for this data? Well, what's the lowest data point? 5. And the highest is 40. And then Q1 we got 17. Q2 we got 22.5. Q3 was 28. You're going to love this. I'm not being sarcastic. Sometimes I'm being sarcastic myself. See if I have enough room here. I'm going to make a scale that fits all these numbers in. Let me see if I can do what I just said. Let's see if I do 15, 25, 35, 45. Sure, that'll work. So there's 40 right there. All right, let me let that... 15. So it's 10, 10, 10, 10. Right? So the scale is consistent. This is huge for me, and actually this is huge not just for me, it's just huge for everybody. Right? It's not huge, but it's huge. Scale has always got to be consistent. You don't make this, there's 5, there's 17, now I see what you're saying. You don't do this, or else I'm going to be all snarky and say, oh really? 2.5 and 12 are the same distance. Do you see what I'm saying? That's not good, because then you're visually misleading people. So that's why your scale has to be consistent, or else you're not showing people how things fall. Okay, that's right. So here's, you're not going to believe me, but you just put a line over each of these. So what do I mean by that? Put a line over 5. Put a line over where 17 roughly is. 22.5. 28. Let's see, where would you be? And 40. Alright. You can make whatever sound effect you want. And you know, if you want to make your scale, you want to resolve it a little bit better, you can make your scale smaller than 10. Whatever you got to do. I didn't have much room to work with. The middle 3, you put a box around it. And then the outer ones, some whiskers. I mean, that's why it's called box. A whisker plot makes sense.
But you said between Q1 and Q3, but you make a box?
Yeah, so between Q1 and Q3. So can somebody tell me what percent of the data is in here?
50.
50. Now this is what? This is Q3 here, right? So how much is below that Q3? 75. But how much is below this?
25.
So that must be 50% in the middle.
Mm-hmm.
So if you look at, like, if you're thinking about where to transfer for college, anybody ever heard of the Princeton Review of Colleges? Anybody ever heard of that? some of you guys, they always give you the middle 50%. That's like the heartland of GPA. They give you the middle 50% spread of GPA. The middle 50% spread of SATs. And it's supposed to give you an idea of cut out the extremes, right? The crazy person that was born with all the knowledge in the world and the person down here that's like, I don't know shit. And just talk about the heartland. Here's what really makes up the heart of our student body. That's what it's supposed to do, the 50% in the middle. All right. And what's the difference between Q1 and Q3? What do you get when you subtract them?
19, 11.
11. And that's what's called the interquartile range. Remember the range was high minus low?
Mm-hmm.
So the interquartile range is just Q3 minus Q1. It's just one step in. So in this case it would be 11. So it's the spread of that middle heartland group. I like it. What am I forgetting? Oh, yeah. So let's say that this is, I don't know, Jeff. Sure. Oh. Oh, 28 minus 17, yeah. Interquartile range is Q3 minus Q1. Always. That's what it's defined to be. So it's like one step in from the range is high minus low. Interquartile range is one step in. It's the inner quartiles. Q3 minus Q1. This is like Q0 and Q4 if you want to get crazy. Let's get crazy. Alright. So the interquartile range in there. So a lot of sound effects today. So say this is grades on a 50-point quiz. You guys with me? Mm-hmm. That's something that this could represent, right? This poor person here. So if I had another class that took that same quiz and theirs looked like this, oh, get out of there, you extra line. Let's make it, sure.
That's a sad quiz.
Let's make it.
That is a sad class. Let's take him out for ice cream.
Now, did they get as low as these guys got? No, but did they do better than these guys?
No.
No. Where's the middle 50%? Isn't it like not as far up as that?
Yeah.
There's less variation.
Yeah, good. One thing I can see is there's less variation. It doesn't, the range is smaller. It doesn't go as far. I like it. You guys with me? Mm-hmm. And then if I had another class, maybe they look like this. Yeah. Right? So they got, in fact, let me even make that go to 0. Sure. But I would still say that this class did the best.
Yeah.
How many people got between these two? What percentage of the people got between these two?
25.
25%. Is everybody cool with where that came from?
Yeah.
Some of you guys are like, there's lines and boxes. Where the hell did you get 25? Well, because of that line means Q1. Because 25% of the people are here. Right? Which means 75% of the people got above that grade.
Yeah.
Well, shit, yeah, that they did the best, even though they had somebody got the lowest possible, the lowest score of everybody. Overall, they did the best. So my point is, this is exactly the point of the first parts of chapter 2. Quick visualizations of data so you can make comparisons between different data groups. This is not good enough for some things, though. I want to get more detail, so that's when we're going to start doing the real calculations and the real formulas of statistics. So we make some more detailed analysis, right? And you're all like, why? I'm good with this. I'm good with boxes and whiskers. Why do we got to do other shit? All right, so to be honest, we just did up through section 2.4, believe it or not. What are we insane? 2.3 and 2.4 really should be one section. Because once you understand percentiles and quartiles, this is just drawing a bunch of lines over the numbers. Ooh, right? But they make it 2 different sections. I don't know why. All right. Anything before I let us out of here? Not too early, but oh well. Okay. That's plenty for today.
I need to go mentally reevaluate.
By the way, we're having a quiz tomorrow.
Oh.
This is going to be an individual quiz.
Oh.
2-1 and 2-2. Quiz on 2-1 and 2-2 tomorrow. We'll first start with a little review before we do the quiz. So. It won't be right off the bat. 2-1 and 2-2. Oh, thank you.